to start with the question.
Yeah, sure. So some of the questions that were regarding the installation of the project itself, so the scaffold. So myself, like I'm using Windows and I had the WSL already installed for the previous blockchain activities I had. So I'm familiar with that. And for all the students, I forwarded the links for the installation of WSL, and that shouldn't be the problem. But what I encountered as a problem was the installation of the scaffold project itself. So using the actual build through the build commands was not viable for me. So I had to like pull the project through Git and then run the yarn install and then set up everything. In that order of steps, everything mostly worked for me. I say mostly because, as Vladislav also mentioned, some of the errors occur during the installation, like warnings, a lot of the deprecating dependencies, etc. So I don't know if any of those should be a concern. And if you have any, let's say, info about like specific version of Node that should be installed, I realized that maybe Node version 20 was something that was working for everything. Because, for example, on 22, everything on scaffold was working, but for the first thing on a challenge 0 wasn't working because I had to switch to version 20. So I was switching between 20 and 22 for class and for challenges. So should we maybe stick to Node version 20? Is that the best option?
Yeah, yeah, I think that's probably best. I mean, 20 usually works pretty well. Sometimes I have to switch to 18 for like some repos or some packages. But it really depends on the flavor of scaffold ETH. Like if you're just doing the vanilla one, I think 20 should be fine. And yeah, those warnings that say like, oh, this package is deprecated or like going to be deprecated soon, you don't have to worry about that. Usually, and it's interesting that you had a problem where the npx command didn't work, but then you were able to use git clone. That's a weird one. I'd love to hear more about that, maybe offline, because that sounds like another issue. But if you're using version 20, it should work great.
I will try to install using npx with version 20. So maybe there was a problem because I was using 22. Because when I installed it once with git clone, everything worked fine, so I wasn't troubled with that anymore. But I will try that and test it, and I will let you know if there is any issue with the version 20. Second thing I will maybe ask there is, I wasn't sure. The commands when we ran the blockchain chain itself, and we got the burner wallets. So I wasn't sure where do we use the burner wallet, because we registered, I have my own MetaMask and I connected my own MetaMask to the application and everything. So I wasn't sure when and in which form we can use the burner wallets.
Yeah, so the burner wallets are kind of just like a nice to have, like you don't need to use it. You can use MetaMask. There's some issues with MetaMask when you connect your MetaMask to a local chain, like running on your local machine. What happens is every time you make a transaction, you have this thing called a nonce, and that nonce increases. So it's kind of like a counter. It's kind of like the amount of times that you use something, so you can't double spend. So it's similar to like like a ledger, right? Like it's a new line. So that nonce changes. And so for a local machine that's running a local chain, Hardhat doesn't understand that that nonce will get reset. And so you might go try to make a transaction later with a different version of scaffold ETH and you'll get an error. So it's not advised to, when you're doing local development, to use Hardhat and instead just use the burner wallet. So you can just disconnect from MetaMask and then use connect and then go burner wallet. And that way the burner wallet is actually stored inside the web application. It's not stored inside the chain. It's running in React. So the private key and the public key are stored in memory inside of the browser storage. So it's not a secure way, but it's great for local.
Yeah, for development. Yeah, I get that. Because the way when you mentioned the error, I did occur the error, but I found a way to just refresh that on my MetaMask account. There is an option to flash that information. So that's what I did, and then it worked.
Yeah, you have to go in and reset it.
Yeah. Yeah.
Which works,
So I
it's
did do that. So that's when one of the problems was fixed. What I had an issue as well with so I don't know if that's the same for the challenge 0, because I was starting to do challenge 0 and I defaultly did it with my MetaMask. So it didn't work with my MetaMask and I needed to use burner wallets for me to finish the challenge 0. So just would have that on record for anyone else who will be doing the challenges. I think I didn't find an option how to set up my MetaMask to work with challenge 0.
okay. Yeah, there could have been some, I don't know why it wouldn't have worked, but
It didn't want to mint the NFT, like it wasn't showing in my like portfolio. It wasn't showing anything on the web app. Just I will screenshot the error that I was getting, so maybe we can discuss it in the Discord
okay.
later. Yeah.
Yeah, no problem.
But yeah, that would probably be mostly of questions that were coming to me and then from my side as well. So I don't know about the guys from Romania that just joined and about their question.
Yeah, if anyone has a question, please feel free to drop it in chat or you can come off mute. If you're just joining, my name is Kevin. I'm a developer relations engineer and educator, so I'm here to help you guys. I'm going to teach you a session about smart contracts today, but I'm here to answer any questions you guys might have just to start.
I just want to add, when we did the burner wallet, the main thing, I recovered my lost wallets and phrases and everything. So it's a very important thing not to miss. Now I have that written down. So thanks to Tamara, almost
Nice.
left me with not serious cash, but some funds. But also an important thing is like also some of the students will face the command prompt, that kind of stuff, like list of commands. It's easy, but let's have I don't know, maybe some link on the material, and also to change and to add to install Node version 20 in order to work everything, for everything to work just fine. And also later on, when we go through the assignment or just the critical points, I would like to ask something when we get there. But first, I would like to hear from Romanian side. They had come across some obstacles and have some suggestions. I'm switching off.
Hello, can you hear me?
Yep.
Yeah, sorry for the delay. I had some network issues, and yeah, everything seems fine now. Nice to meet you all. And yeah, for now I don't have any question in particular. I tried to follow the things, and yeah, I'll watch and I'll hop in if I have any question.
Yeah, for sure. If something comes up, just let me know.
Yeah.
There is a Discord channel, and then I'll try to, maybe I can get invited to the WhatsApp channel or something to keep an eye on it. But yeah, feel free to email me as well, kevin@edgenode.com. All my contact info is in the Notion page, and I'll share that again just so you guys have it.
So maybe I can.
Great.
I can come with yeah, some observations related to the basic of the whole program. I just enrolled the two guys who are here, Alin and Sebastian, recently, and in some way I followed their process of registration and all the preparatory part of the the participation, and definitely the Serbian organizers should work on the registration form that shouldn't be in Serbian but in English, and also maybe they can automate a bit the process of sending instructions, and even the registration form is not sending the initial confirmation of the registration, so it should be definitely more friendly and interactive, and then all this deeper technical stuff I'm not able to comment or to raise questions, as I'm not a technical guy, but I've also seen that Aline faced some problems in setting up the Node.js 18 and then next levels of components needed in the working environment.
That's important. We texted each other in the private messages, but Aline, please, when you come across any obstacles, screenshot it. Like I talked to Kevin just before we started recording. I screenshot like some other installations for the homework, so I will be posting that on Discord. It's the easiest way. Okay, you can contact Kevin as well directly, or Tamara. They are technical stuff here, but please feel whatever which is easier for you. I'm suggesting Discord. It's easy. You can upload those screenshots with the questions, and it will be soon answered.
All right, thanks. Can you hear me, by the way?
Yep.
Okay. All right.
We can. Okay. So let's start from the beginning, like a short thing, if you can, Kevin, and then go through this homework, just essential, and then session number 3.
Oh, okay. So you want me to go over when you say at the beginning?
Not in details. They already seen the things. Just a quick thing.
Gotcha. Yeah, for sure. Let me do that for you. Cool. Let me share my screen real quick. So again, everyone, thank you for joining. My name is Kevin. This is the 3rd session. So this 3rd session is kind of focused on smart contracts as a whole. Everything that we're going to be doing in this session revolves around scaffold ETH. I think you guys kind of understood what it is, but it is essentially a package that comes with everything you need to get started, right? It is Node.js. It runs with React. It has Hardhat or Foundry as a chain. It has a lot of boilerplate code. There's a lot of extensions that you can use. And so we're going to be using that primarily to do some of the work. And then as far as the curriculum goes, I posted it in the chat, but I think so far we've kind of gone through, and the first session was kind of an introduction of what it means to actually build a dApp or a decentralized application on specifically Ethereum. And then we gave some homework. Last time we did a session on Ethereum virtual machine, essentially how Ethereum works under the hood, and kind of dove in a little bit more into detail about the Solidity and the syntax and how you write smart contracts with Solidity. And then today the goal is to cover session 3, which is more in depth about the standards, the token standards like ERC20, ERC721 and stuff like that, and the difference between like fungible and non-fungible. And then we'll actually build and deploy an actual token on this call. Is there anything else you want me to cover, Vlad, specifically?
No. Just like this is like a short because we have to do the session 3, and I hope new questions will come before session number 4.
Cool. Okay, cool. All right, so yeah, so we're going to be doing session 3. This is inside the chat here. Essentially, what I want to talk today about is just the like the core principles of like writing a smart contract and what they bring to the table when it comes to Ethereum. So if we think of like the very first cryptocurrency that really had mass adoption, we think of like Bitcoin, right? Bitcoin's great because it is a store of value, and it is I would say it's a medium of exchange now in some countries, and it's getting a lot of traction for a reserve currency, right? It's used as a cryptocurrency. But the thing that Bitcoin lacks is the ability to have this kind of smart contract technology. And so, the original creator of Ethereum wanted to kind of redesign Bitcoin in a new way, and that's how Ethereum was born, right? So it's this idea that we can take the traditional methods of like dealing with a bank or some kind of third party to do contracts between value, and then executing those in a more traditional way and doing these in a more automated way using code. So using infrastructure as code, as you would say. And that's what a smart contract is. It's just a piece of software that lives on the blockchain in a immutable, trustless, permissionless, open way that anyone can interact with. And kind of like you can deploy these smart contracts as almost like vending machines or APIs that can live on forever. And if you program them correctly, they can do some really interesting things. So I kind of put some information here on like more into what a smart contract is. I think we all kind of understand the basic concepts, but I want to talk a little bit more about like the standardization, so the types of tokens. So the very first form of asset that came with Ethereum was what's called the Coinbase. So the Coinbase is like the very base like token that lives on that chain. So if you heard of ETH, right? ETH is the Coinbase cryptocurrency for the Ethereum chain, and that's what everything runs on for gas. And that's how the main transaction of funds work. But what smart contracts give you the ability to do is to do this concept of like additional tokens, right? So ERC20 is kind of like the standard. So ERC20 was created as a way to allow other people to create tokens for different real world use cases, right? So some of the most popular tokens are like stable coins, which are like tied to, in this case, the USDC or the USDT is tied to the price of the dollar. We also have like utility tokens like the graph, like we have the GRT, which is a utility token. It's used to do things on the network. Same thing with Link, which is Chainlink. That's used to do things on the network. And then there's like little silly coins that maybe don't have as much utility, like Shiba Inu and Pepe and like meme coins and kind of non-utility coins, right? So there's this kind of spectrum of like, you can see just by having one single token standard, we're able to open that up, right? And then we think about like, you guys have heard of NFTs. NFTs are interesting because they open up another use case for a token. And the main difference is that we talk about something that's fungible versus something that's non-fungible. So cash is a perfect example of something that's very, very fungible, right? You can have like 1,000 or 1,000,000 of one single denomination, and that can have the same value, right? It's fungible. Same thing goes with Bitcoin, right? Bitcoin is very fungible. Ethereum and all these ERC20 tokens are very fungible, right? You can have many of those. But we think about things that are non-fungible, and NFT, right? That's what non-fungible is. We can think of like art. It's art that's unique and one of its kind, or we can think of it in the NFT space, which is like something like a CryptoPunk or a Bored Ape or something like that. And this is a concept of creating tokens that are very unique. But these also, other than these like Bored Apes and CryptoPunks, which are kind of just like speculative kind of like tokens, there's also utility NFTs. So a lot of people think like, oh, NFTs are like kind of silly and stupid, which in some ways they are. But you can also program NFTs to do more complex things like storing ENS names, ENS resolutions. So having like a domain name kind of resolution system on Ethereum, that's ENS. There's also subgraphs, which are like the graph. Those are also NFTs. And so you can program these NFTs in a way that you can use them to create complex or cool applications using this standard, right? There's also ERC 1155, which is kind of a mix between the two, which allows you to do like fungible and non-fungible assets, but you can create like multiple instances of those. So in other words, like if you wanted to have 2 Mona Lisas or 100 Mona Lisas, and it's kind of like limited edition, there's a way to do that as well. Or if you wanted to do, some other kind of like method. It's commonly, the ERC 1155 is a great standard for doing like token gated access, because you can have one contract where you can like mint as many NFTs as you need in there. I've used it many times. So now I want to talk about like, I think you kind of understand the basics of a smart contract. You understand there's different kinds of smart contracts and tokens specifically. But where do you go to get industry standard smart contracts? So if you're kind of just messing around and you want to like learn about smart contracts, I've already talked that you can go to Solidity by Example. There's a lot of complete full examples on there that are really good. But there's also a really good platform called cookbook.dev. I don't know if anyone's heard of this before, but Cookbook Dev is a really cool platform because you can come in here, and if my internet is working, I don't know why it's a little slow. Let me go here. Okay. You can search for any kind of contract you want. So like if I click this little search keyboard, it brings up and tells me exactly the most popular token is the OpenZeppelin simple ERC20 token. There's also an Aave, there's a Satoshi viral token. There's all sorts of these examples. Uniswap is on here. Any kind of smart, even BiddleGiddle. BiddleGiddle has some contracts that are on here. So any contract that's been written that is got wide adoption probably is going to be on here, and any kind of standard is going to be available on here. So if I do like ERC 721 and do a search, we should be able to search and find all of the ERC 721 contracts. So there's some by Third Web, there's some by Umswap, Rmark, and so you can kind of look at these as examples and starting points. So you know, like, oh, okay, I want to build an NFT that is, been widely adopted. Well, here's the Third Web version. And we can come in here and look at the code, and we can like read it and maybe make some decisions about, is that how we want to do our code? Or we can use it as a reference, or we can just copy it and actually load it into our thing. So you can do that by coming down here and say open and remix, or you can download it directly into a Scaffold ETH package as well, which is really cool. So you can literally click this button and it will spin up a project instead of a zip file that you can extract, and then you have your working project there. Only thing you need to do is fix the deploy script. So it's really cool if you want to search for tokens. Also, all the OpenZeppelin ones are great. So if you go to OpenZeppelin, if I can spell that right, all the OpenZeppelin examples are very good. OpenZeppelin is a security company. They do like auditing and automation for smart contracts and for chains. But they were originally like kind of made famous because of their standards. So they created standards contracts that can be reused, that have the highest level of security. So in other words, they're the safest tokens as a starting point. And so if you're going to start with a token, you should probably look at OpenZeppelin. Yeah, you can also go to OpenZeppelin. I think it's in the link. If we click on OpenZeppelin here, there's a really cool tool here on the OpenZeppelin website where you can search for exactly what you want, and you can edit it inside the browser. So let's say I want an ERC 721. I want it to be called, I don't know, Serbia token, and we'll do SERB, something like that. And we could put in the URI right here, and we can make it mintable, we can make it burnable, we can make it pausable, we can have it have storage. We can have voting on there. We can have ownable, which is access control. We can basically create a smart contract just using this little wizard right here. We can also put a security contact and a license in there. And then we have this entire contract that we can copy to the clipboard, or we can open it in Remix, or we can deploy it with their automation tool, which is called Defender, or we can just download it. So it's a really cool tool if you're just starting out and you don't know what a good starting point is. And you just want to have that, you can come in here and do that. Okay, So OpenZeppelin is great for access control contracts. We're going to set one up today. So they're also great for all the tokens that they have. They have ERC20 standard, 721, 1155. They have utility tokens that allow you to do like things like math, overflow protection, signature verification, all sorts of stuff like that. And there's also a bunch of tools like counters. There's a lot of methods and functions that are built into them that just make it so you don't mess up and do things the wrong way when you're first starting out, and you'll get weird errors in your application. So look at OpenZeppelin. It's a great starting point. Okay, so I think you guys have a base understanding of what a token is, why you need one, why you need a smart contract. What I want to do now is let's go through the process like we're going to start up a new project. And what we're going to do is kind of like gut scaffold ETH a little bit and show the process again. And then we're going to slowly implement an OpenZeppelin ERC20 with ownable, and we have to take control of the contract. And we're going to go through and build a token out of the smart contract. Okay, so let's do that now. So I'm going to just get started. We're going to do npx create-eth at latest, and we'll just call them this token example. Sure, token example. So this is going to ask me if I want to install the package. So if you are just getting started with Scaffold ETH, if you go to scaffoldeth.io and you go to the GitHub, there's going to be a link to all the dependencies. So we just talked about it. Install node version 18 or above. I would say 20 is a good one. Make sure you have a Yarn package manager, the newest version of Yarn, and make sure you have Git. If you have those three things, you should be fine. And yeah, we can help you if you get stuck, but we're going to say yes. So npx is the command line interactive way to install Scaffold ETH. You can technically install it with git clone, but we're going to use npx. If you want to use git clone, the steps are in the GitHub repo, but we're going to use the npx method. So I always use Hardhat. You can use Foundry if you prefer, but Hardhat is just been around a little longer. It's easier to find documentation for. Foundry, you can write your smart contract tests in Solidity language versus JavaScript. Hardhat is all in JavaScript or TypeScript. I'm going to use Hardhat. So this is going to create a project for us out from scratch. It's going to install the dependencies. It's also going to format the files for us so that there's no like weird syntax, and it's going to initialize an empty Git repository. This way, if you want to save what you've been working on, you can just go into Git, create a repository, and then paste in the commands to upload everything to Git. So it's really nice to just kind of have a starting point. Okay, so we'll let that install for a second. So what are we going to do today? We're going to first start out with a gutted contract. So Scaffold ETH comes with a contract. We're going to kind of erase everything and start at this very, very basic starting point, okay? And we have that here now. So let's go ahead and go into the token example. Now, we talked about it before, but if this is your first time, you always have to have a few windows open with Scaffold ETH because you need one to run your chain, you need one to run your front end, and you need one to like do all of your deploys, okay? So we're going to do Yarn chain in this one, and then we're going to spin up another window, and we're going to bring up our front end in this window. So I'm using a tool called Tmux, T-M-U-X, which is a really cool tool just for splitting your screen. But it's a little complicated to use, but it's really nice if you can get it down. So I'm going to go into this third window, and then I could deploy our contract, but I want to wait a sec. I want to actually load up our project in VS Code. So let's do that. And let's see what it looks like. So if you're coming into Scaffold ETH for the first time, it's a mono repo. So it has these two folders in the packages folder. It has a Hardhat package for all the backend, the chain, and Next.js for the front end. So what we want to do right now is just focus on the backend. We're going to go into the contracts folder, and we're going to go to your contract. Your contract Sol is the contract that comes with Scaffold ETH. I'm going to just kind of rip out some of this stuff that we don't necessarily need right now. So I'm going to take this out. I'm going to take this comment out. I'm going to take this out. I'm going to just completely gut all the variables in the events. And I'm going to get all this, all the functions. I'm going to leave that one function there because it's kind of a nice function, and I'll explain what I'm doing right now. But okay, so I'm just starting at this very empty kind of like skeleton project. So what I did is I took away everything that's in there. So all we have is just the version to use. So this is the versioning to use this pragma. And this says use between 8 and 9. So whatever compiler, the highest compiler available between 8 and 9. Use the Hardhat console so we can print stuff to the console if we want, which is really nice for like debugging. I'm going to import this later, so I'm just going to keep it there so I don't have to type it again later. We called the contract your contract. It has an empty constructor, and it has this default function that allows us to receive ETH. So if in case someone sends ETH there, it will still receive the ETH versus failing. This is kind of like a fallback. It's called a receive function. So we have this very basic contract. And if I try to deploy that right now, I just saved it. I took everything out of it. And if I try to deploy, it's going to give me an error. It's going to tell me, it's going to give me a couple errors. The first error is going to tell me that, well, I was trying to pass an argument. It's going to be a very ugly error, but it's going to say we were trying to pass an argument in our constructor. It expected nothing, but it got one argument. Now, if we come back into Scaffold ETH and we go to the deploy folder and we look down below, there's these files. These are your deploy scripts. There's for every single contract, you would have a separate deploy script. And then we have this generate TSABI, which generates all of the types for our contract. But the main deploy script is this one here. This is the one that deploys this contract called your contract, right? So we use Hardhat because we're using Hardhat to do the deploy. Let me just clean this up so it's easier to read. So what we're doing here is we're saying, okay, let's use Hardhat to do a deploy. And let's figure out how we're going to deploy it by getting the signer. And so we do that by using this get named accounts. So we say we want to know who the deployer is going to be right here. So this is a variable we define. And by calling get named accounts, this comes from Hardhat. So this is Hardhat get named accounts. What it's going to do is it's going to use the very, very first account as the deployer. So the signer, we talked about transactions in the very first one. You have to sign a transaction every time you update something on the blockchain, or if you want to create a contract. So when you deploy, you're basically signing a transaction with all of the bytecode and you're pushing it. So what this is doing is saying, okay, use this first signer out of Hardhat, which is these accounts that come with Hardhat, which are here. You see these account keys and private keys. So it's going to use account number 0 to sign the transaction with that private key. And it's going to use the public key right here from account number 0 to deploy it. So it does that by doing the deploy of the contract, and then we're passing this argument in the deploy. Everything in the arguments goes to the constructor. So if you wanted to do anything inside of this constructor, like let's say you wanted to pass an address, you have to do it like this, and then pass who it's going to be, like owner. We're going to do it in a little bit. And then you can pass things into the constructor. The constructor is something that gets deployed at the very first time the contract is deployed, and then that's it. So it's kind of like an initialization of the smart contract. Okay, so let's go ahead and get rid of that argument. So we're just going to get rid of it. So we're going to save that, and then we try to do a deploy again. And we're going to get another error, but this time we're going to get something different. It's going to say your contract greeting is not a function. And that's because also we were doing right here, if you look below, after we deploy the contract here, we get a copy of the contract as a variable called your contract. So we say, okay, call Hardhat Ethers. Ethers is a package that allows you to interact with the blockchain using an SDK, essentially. Ethers is an SDK. And we can call the contract by calling a get contract and get a copy of the contract using the deployer as a signer. So here we deployed the contract. Here we get an instance of the contract to interact with. And then here we tried to call console log your greeting, but it doesn't exist anymore because I deleted it. So we're getting that error because greeting is not a function. So let's get rid of that then. So let's go back to the deploy and let's just get rid of this line. Save. So now it should deploy successfully. There it goes. So now it was successful. We'd see right here that it says nothing to compile, but it reused your contract and it compiled, or it deployed it. So we're in good shape now. So let's look at Scaffold ETH real quick, and we can see what that looks like. So we're going to go to localhost port 3000. And it's very boring. There's nothing in there, but let's just take a look to make sure that it's empty. So here we go. Oh, this is the wrong one. It's on port 3001. Sorry. That's another project I'm working on. For you guys, it'll be on port 3000 probably, unless you have another version of Scaffold ETH running. There we go. Okay, Scaffold ETH is running on 3001. We can see that right here. It says listening on 3001. So if we go to debug contracts, and let me disconnect from that. So the burner wallet, it's empty. There's nothing here, right? What we want to do is start building the contract. So let's add some stuff to the contract. The first thing I want to talk about is ownable. So we talked about OpenZeppelin. So Scaffold ETH comes with all the OpenZeppelin contracts. So you can actually like click on them and see what they look like. If you want to look at the ownable contract, you just hold down Command and you can click on it. If you're using VS Code, you can also look down below. I think that it's under node modules. And then we can go to OpenZeppelin. Let's see, somewhere in here at OpenZeppelin. Where are they at? Right here. Here you go. And then we have all the contracts in here as well. But these are all the OpenZeppelin contracts that come with Scaffold ETH. So we're going to use Ownable. So Ownable is an access control contract, and it allows you to just basically take control of the contract as an owner. So it's kind of like you don't want to deploy a contract that you have no control over, because if funds get deposited in there and you want to get them out later, you need to have that private key and public key that owns the contract. So to do that, we're just going to import. So you import and then you inherit. So we say your contract is ownable. So we import and then we inherit. And then it's going to give us an error that we haven't passed the arguments to the constructor. We need to pass those. So that's because just like we had a constructor argument before, we now need to pass a new one called the owner. So we need to specify who the owner is. So we can go down here and we can do that. So we can say ownable, and we can say who the owner is going to be. Now, if we wanted to use Hardhat, we could use the message.sender, right? We could do that. And that would actually deploy using the thing. But maybe you want to like control who the owner is. Let's just see what that looks like. Let's see if that works. Let's try to deploy it. So yarn deploy. Yeah, that worked. So now if we look at Scaffold ETH and we look at the owner, it's this 0xF39F. But that's not an address that I have control of. That is the Hardhat account, which is one of these ones that was up here in the console. So we actually want to use a private key. So let's use the burner wallet. So let's copy this address because we have the access to the private key in here. At least I think we do. Let's copy the address and let's do it a different way. So let's go to the deploy script and let's define who the owner should be. So owner should be this guy. And it needs to be a string. So you need to like put it into quotes like this. And then we can pass the owner here. Okay, so we have this owner that we define, right, using TypeScript, and we pass it to the argument. So now we can set our contract to take in that argument. So let's get rid of message sender. And let's say that it takes in an address called owner. Now, the best practice is when you're taking in a address or taking in a variable, you do an underscore in the beginning. And then when you're using that as a hard-coded, like a local variable or like a long-term storage, you do not count, just a regular owner. And then we can pass that here. So basically what we do is we take in the owner here in the constructor and we pass it to the ownable constructor. So every contract has its own constructor. So that's important to understand. So the minute I add another contract, I'll need to have another constructor here for that contract. And that's because they're kind of like Legos. They go on top of each other, but they still have their own kind of like core functionality. So we are passing this address to the argument. which is getting taken in our constructor. It's an address, and we pass it to our ownable construct and hit save. Now let's deploy again. And let's go back to scaffold ETH once it's done. Hopefully I did it right. Yep, there we go. So now if we go to scaffold ETH, it's going to refresh automatically. Now we have the burner wallet here as that. So it worked, right? It worked. We could also set the owner to Vitalik if we wanted to. We could do Vitalik.eth, grab his address, and we could come over here to the contract and go to the deploy and paste it in and hit save and then deploy again. And you see what we're doing. We're just kind of like toying around and seeing what happens. And now if we go here, let's see if Vitalik's the owner. There he is. Vitalik now owns this contract. So you have a lot of flexibility on like that ownership. Now he's the owner of the contract. So he's the only one that can transfer ownership, and he's the only one that can renounce his ownership. So let's put it back to one we control. So let's put it back to here. Oh, save, owner, save, deploy again. I just want to show you something. So we could redeploy that, and then we'll get back the ownership, and then I could pass it. Like I want to send it to myself. I could say, well, let's transfer it to, let's transfer it to Austin. ATG.eth, there's Austin Griffith. I can send it to him. I need some money to pay for gas. Need to click that, get some gas, hit send. There we go. Now Austin's the owner. So he's the owner of this contract. It's running locally. It's not like deployed anywhere, but you get the idea. So we have this ability to transfer. So this comes with OpenZeppelin ownable, all this stuff. Everything we've been doing is all OpenZeppelin. So it's simple. It's just like some modifiers and some functions and variables, and that's it. Okay, so let me redeploy so we get back to the contract. But now let's do a token. We have like 10 minutes. I'm going to just try to deploy a simple token. There's two ways to do a token. The way that I want you guys to do it is I want you guys to go to the thing here, and I want you to follow along, and I want you guys to do it the hard way. So there's this build your own basic ERC20 medium difficulty. It's called medium difficulty. It's a little hard, but the idea is I want you to build a token using the knowledge that you know about Solidity already that you may have learned over the last couple of weeks, and use that to build a token by manually building it out from scratch. So you need to have a string and another string and an unsigned integer and another unsigned integer and a mapping to keep track of balances. You probably want to have events so you can keep track of when tokens are transferred around, right? You also want to probably have a total supply. You also want to be able to transfer a function to transfer stuff around. You also probably want to keep track of who the senders are of the tokens and what their value is that they're sending. And so this is a guide on how you can deploy a token without using OpenZeppelin, just for fun as a thing. But we're going to use OpenZeppelin. So we're going to do this easy difficulty section here, which you could do. So here it is. All we got to do is import OpenZeppelin ERC20 like this. So let's grab it and go here. So now we're going to use the OpenZeppelin ERC20 standard. We're going to say that our token is ownable and it's ERC20. What is it going to need? Well, it needs a name and it needs a symbol, just like any token. So we can come down here and say ERC20, and we can call it the Pupin token. Pupin's token. Okay, yeah, there we go. And then we'll do yeah, P-U-P-P, two P's, right? Okay, there we go. So this is the Pupin's token. And am I saying that right? I hope I'm saying that right. So we hit save, and now let's see if it lets us deploy that. Very simple. All I did was add one line of code, add the constructor, and I hit deploy. And there it goes. It deployed successfully. So let's take a look at C in scaffold ETH. So here we go. Just because we use ERC20 token standard, we now have a token that has 18 decimals, a total supply of 0, because we didn't initialize the supply, but that's okay. We'll do that. We'll fix that. It has a symbol called Pupin, Pupin's token. It has all these read and write functions that come with the ERC20 standard. So those are to be able to read what your allowance is for spending. ERC20 has this interesting pattern where it's kind of like your bank account has on your credit card, where you need to allow a certain limit to what you can spend. Like you might have $100,000 in your bank account, but your credit card only allows you to spend 10,000, right? So ERC20 has this thing so you can set an allowance. It's kind of like your spending limit. So you could say, well, I want to allow this contract to only deploy, to use my tokens up to this value. It's called the allowance pattern or the approve pattern. So you have to be able to approve spending. So you say who's going to spend it and how much they're going to spend and then send that. So we get that automatically. We get the allowance, the approve, we get the balance, and we get the transfer function. So let's set a balance. So let's say we need to mint to the owner. Yeah, this many tokens. I don't know, that's a lot. Let's do this. 777. That's going to be a lot easier to see. Okay, 777. So this is going to be, I think it's going to be times 10 to the 18th power, like that. Yeah. So we actually need to do, so when we're talking about tokens, and especially if we talk about like Ether is has a set amount of like 1 ETH has additional decimals, right? Just like Bitcoin, you can own a fraction of a Bitcoin, you can own a fraction of an ETH. So what we do is if we want to have 777 tokens, we need to multiply that by 10 to the 18th power to be able to get the full 18 decimals that come after the 777. So this would allow us to take that 777 Pupin token and split it up into a 0.0000000 all the way down to 18 decimals to the end. So that's how we do that. So we do that. Now let's deploy it. And it should be good. Let's see. There we go. Is it deployed? Okay. So now we have a total supply of 777 tokens, Ether status. This much is how many tokens we have. So we have 777 and 18 zeros. So we have a lot of these tokens. So now I can send some. I'm going to send some to, I don't know, Vitalik. Sure. Vitalik.eth. I want to send him 100 tokens. Now, if I send him 100, I'm only going to send him 100 way of the tokens. I want to send him the 100 actual tokens. So I need to click this little button, which will multiply that by 10 to the 18th power. So remember, we always want to talk we're doing way when we're typing in here, but we want to transact, in way. So we're thinking a mental model 100 tokens here, but we click this, it will convert it to way for us. Send. There we go. So now I just sent Vitalik. So if we go to my balance, now I'll only have 677. Let's see. Let me refresh. Oh, that's weird. It said it worked, but didn't update. Let me see. Oh, weird. It let me send him tokens, but it didn't. Oh, that's the total supply. Sorry. Yeah. So now if I look at my supply here, there we go. So I have 677 tokens and Vitalik has 100 tokens. Okay. So we created a token pretty easily, right? Just by adding, we deleted everything from our contract. And here we have a contract that's access controlled and it's a token and it has a supply and that's it. It's literally like 16 lines of code. And there's even some space here. So it's very, very, very optimal and easy just to use OpenZeppelin contracts to do that. Okay. Okay. So at this point, I'm not going to go into like how you would deploy the contract because I kind of have showed that a little bit. We'll go into more detail about how you push your contract to a test net, probably when we have more time. Probably not. Well, yeah, we might do it actually next week or the week after. But for sure, we will teach you how to deploy this on a public blockchain. But for right now, everything's been local. It's actually pretty easy to do. You would just need to generate an account. So we don't want to use the private key that come with Hardhat or Foundry. And the reason why, sorry, we need to run yarn generate. We don't want to use those private keys that come with Hardhat or Foundry because they're shared keys. Everyone has the same ones. So the minute you want to push your smart contract to a public blockchain, you need to use a generated key. So you can type yarn generate, and it will generate a private key and a public key for you. So it puts it into their env file. If you're using Foundry, it puts it into your key store. But yeah, it creates the env file, and it gives you this public address. So then you can, later on when no one's looking, you can go into this file right here, which is in packages Hardhat. It's inside here, and you can write down that number. And that's your like password, right? That you don't want to share that with anyone. But then if I wanted to deploy that, I just need to fund this account. So let's do it right here. So I have this account here. That's the address. It gives me a QR code, which is really convenient. I can take my phone, which I have like a burner wallet here, and I can scan that address, and I can send myself some ETH from my Punk wallet. So I'm using a Punk wallet. So it's this cool app called Punk Wallet. And so if you go to punkwallet.io, and I have a wallet that I keep just for all my deploys, I've just sent some funds there. Now I can do yarn deploy -- network Sepolia. So I just sent some Sepolia ETH to this address. Let's see if it works. So it's a little slower, obviously. There it goes. It worked. Cool. So I sent some ETH from my phone to my laptop's private key, and then I deployed the contract on Sepolia. And now I can do yarn verify. So you always want to verify your contract, because you might need to like look at that code later, and you might need to like ingest data with the graph, or like it's just best practice to do this. So what that does is if we go to if we go to Sepolia Etherscan, let's just do that real quick. So let's go to Sepolia Etherscan, and we type in that address of what we just created. So I just deployed this contract. It looks like it hasn't completely, there it is. It's the Pupin token, ERC20. It's on Sepolia Etherscan. And yeah, let's see. What else do I need to do? Oh, if we go to contract, it's all like bytecode. So this is not human readable. So we want to verify that contract. So all we have to do is do yarn verify -- network Sepolia like this. That's going to take our contract and send off the source code to Etherscan so that they can compile it and see that it matches the bytecode. If it matches the bytecode, then it's going to verify it as successful, which it did. And now if we come over here, we can refresh and see that syntax here. So now we've deployed a ERC20 on Sepolia, which is the test net for Ethereum, all using scaffold ETH in, like 20 or 30 minutes. And then we verified the contract with 16 lines of code. So really cool. Okay, cool. I think I'm going to stop there. I think I almost made it close to 8. I think we have time for like one question, but hopefully that was useful.
That was great, especially with someone that will reach lesson number 3. We will still communicate with others to send questions in order to follow this with ease. For me as well, I have some things that I have to do slow-mo, and also I had written down a couple of questions on that, but that will be then on Discord for others to see, because most probably others will have the same questions, especially like for the first assignments, just to get to this smart contract. And we all work on that to be as easy as possible. Okay. I think this is the wrap for session number 3.
Awesome. Thank you so much, guys. Thank you everyone for coming. And yeah, if you have questions, please feel free to let me know. And yeah, I'll see you guys next week. Don't miss it.
See you soon. See you next week.
See you. Bye.